Question number 20. Solve the equation. So we have 2x minus 1 over 4 plus x minus 2 over 3 equal to 2. So let's look at these two first. So let's cross multiply. So 2x minus 1 plus 4x minus 2, and then we have to do 4 times 3, which will be 12. Equal to 2, the same. Expand those two, we will have 3 times 2 is 6x minus 3 plus 4x minus 8 over 12 equal to 2. Simplify, we will have 6x plus 10 plus 4 will be 10x, minus 3 minus 11 minus 8 will be minus 11 over 12 equal to 2. So now we have to cross multiply, which is 10x minus 11 equal to 24. So thus, bring this up, we will have 10x equal to 24 plus 11. So 10x will be 35, x will be 35 divided by 10. So if we divide by 5, we will have 7, 2. So 7 over 2, or 3.5 is the value of x. Question number 21. So we are given the volume of a sphere is 4 over 3 pi r cubed. The question now is, so during a storm, raindrops fall into a cylinder which stands on a horizontal ground. So what is a cylinder? It is of the shape like this. That's a cylinder. Has a height and a radius. It's always a circle base and then a height h. Okay, so the cylinder was empty before, so that was empty, and the radius was 20. So radius equal to 20 mm. Okay, and now we have what? It says each raindrop is a sphere of radius 2 mm. Okay, so after a storm, the depth of water in the cylinder is 16 mm. So let's say the depth of water is 16 mm, which means that the water has filled the cylinder to this level, 16 mm. So the question is, calculate the number of drops that fell into the cylinder. So the first question is, what is this volume, right? Find the volume of water that fell into the cylinder. So how do you find the volume of a cylinder? We use a formula of cylinder. E is equal to pi r square h. Pi r square h. So pi times r. R is what? 20 square times h. That's the volume of the water inside the cylinder. Okay, that's the volume of water inside the cylinder. So now let's find the volume of a raindrop, which is 4 over 3 times pi times r cube. R cube is 2 cube. That's the radius of the cylinder. So we need to find the number of drops. So it will be volume of water divided by volume of raindrops to find the number of drops. So it will be pi times 20 squared times 16 divided by pi times 4 over 3 times 2 power 3. So let's bring this up and find the answer. So pi we cut. We have 2 times 2 times 2 is 8. 8, 1, 2. So we have 2 to the power of, so 20 times 20. And then times 2. That's remain. And then bottom will be divided by 4 over 3 will become times 3. So do this. 5. So your answer is 20 times 5, which is 100, times 2, which is 200, times 3, which is 600. So 600 drops fell into the cylinder to form this volume of water? So your answer is 600. Okay, question number 22. So the diagram shows a triangle ABC. We have the triangle ABC. And now we have the question part A. Construct the locus of points inside of the triangle ABC that are equidistant from A and B. So we have to draw the perpendicular bisector of A and B. So we use our compass. So we first have to draw an arc on this side and this side. And with the same length, we go to point B and draw an arc on this side and on this side. So then we can just join the arc together to form the bisector of A and B, the locus of points. So it needs to be inside of the triangle. So I will start here and then go up here. That's the first question. Now the second question is construct the locus of points inside of the triangle that are equidistant from AB and BC. So AB and BC. So we have to draw the bisector of the angle B. Okay. So we use our compass. We go to point B, and we just make a small arc. Let's say do the arc here, and then the same length. I'll make another arc on this side of the line BC and AB. So once I do that, I will go on those points where we have the intersection with the same length, and I will draw an arc on the inside of the triangle. And then I go to this side, do the same thing to intersect and having this point. So once I do have this point, I will join the point B to this point to form the angle bisector of B. So inside of the triangle. So part B is done. Now part C. On the diagram, shade the region inside the triangle which contains the points that are nearer to A than to B. So A is here, B is here. Nearer to A will be on this side. Now nearer to BC than to AB. So AB is this side, BC is this side, so the points will be on this side. So shade this region. This is the required region for part C, and that is the question of 23. Question number 23. The diagram shows a piece of card from which a triangle, this triangle, and two small squares are removed. All length in the diagram are in centimeters. Question number A. Calculate the area of the shaded card. So this card. So we can take the whole area minus the area of these two squares and this triangle. Let's do that. So what is the whole area? Which is 5 times 5 minus what is the area of the triangle? So this is 2, so this is 2, and this is what? This is 5 minus 2 is 3, this is 3, and this is 1, so this will be 4. So area of triangle is half times base times height, and then what is the area of the square? So plus 2 times 2 plus 1 times 1 equal 25 minus, simplify, so 2 times 3 is 6 plus 4 plus 1, which is equal to 25 minus 11, which is equal to 14. So that will be 14 for the first answer, part A. Okay, so now moving on to part B. Find the perimeter of the shaded card. So to find the perimeter, we have to find this side. So we know that by Pythagoras theorem, so 3 square plus 4 square will be 5. So that will be this side, 5. This is 2, this is 2, this is 1, this is 1. And this is 4, and this is 2, this will be 3. So what is the perimeter? Let's begin here. So 3 plus 2 plus 2 plus 5 plus 1 plus 1 plus 4, which will be equal to, so 3 plus 2 is 5, 5 plus 5 is 10, plus 2 is 12, plus 2 is 14, plus 4 is 18. So the perimeter of the shaded region will be 18 centimeters. Question number 24. So in the diagram, we have A, B, C, D, and E lie on the circle, on this big circle, center O. So BOE is a straight line, that is the diameter, so which means this is the radius, this is the radius, and that is the radius. So we have these three sides are equal. Okay, so we have angle DAB as 34. This is 34 DAB. Okay, so question number 1, find angle X. So angle X, as you can see, it is the angle at the center, and it is always twice the angle at the circumference subtended by the same arc. So X is equal to 2 times 34. So X equal to 2 times 34, which is 68. So X will be 68. Okay, so now we have to find part B, which is Y. So we have to observe, so we have this quadrilateral touching all the sides, which is this. This is C, B, A, D. So we need to find Y, and we know this one already. So this value is 34. We need to find Y. So all the side touches the circle. In this case, we have to use the rule of complementary angles, which means, so Y plus 34 is 180. So the Y is 180 minus 34, which is equal to 10 minus 4 is 6, 7 minus 3 is 4, 1. So 146 for angle Y. So angle Y is equal to 146. So now we have to find the angle Z. This is pretty easy. So we know angle X is 68. So what is this angle? It will be 180 minus 68. So 7, 10, that will be 2, 1, 1. So these two is an isosceles triangle, so these two angles will be the same. So 112 divided by 2 will be 5, 6, 56 will be angle Z. So angle Z is equal to 56. And the last one is angle T. So for angle T, we have to use a rule as well. So as you can see, this is the diameter of the circle, and we have a triangle over the diameter. So this angle here will be 90 degrees. So since we know this small one is 34, what is the value of T? So T will be equal to 90 minus 34, which will equal to 8, 10, 6, 5, 8 minus 3 is 5, so 56. So the value of T is also 56. That is the last part of this question. Question number 25. In the diagram, the line 3y plus 2x equal to 13, that's the line, meets the axes at A and B. The first question, part A. Find the coordinates of A. So A is this point. So the line equation is 3y plus 2x equal to 13. So A is a point where it meets with the line x equal to 1. So we replace this value in the equation, we get what? Plus 2 equal to 13. So 3y equal to 13 minus 2. So 3y is 11. Y is 11 over 3, which is 3 and then 2 over 3. That's for y coordinate, and the x is 1. So the answer will be 1 and then 3, 2/3. That's the point A. So now question number B, we have the shaded region R is defined by 5 inequalities. 2 of these are x is less equal to 6, which is this line, this way. And we have y is less or equal to 6, will be the top line. Okay, now we have to write down the other 3 inequalities. So we have this line as well, so everything to the right of this line. So it will be, this line is what? Is x equal to 1, so it will be x greater than or equal to 1. That's the first line. And we have this line as well. It needs to be up, so we have y greater than or equal to 2. And the last one is this line, which will be 3y plus 2x bigger than 13. That's the third line. Okay, now part C. The point P is in the shaded region R. Given that AP is as large as possible, write down the coordinates of P. So from the point A, we have to choose a P where the line AP is as large as possible. So at first sight, you can see it needs to be the extremities. So it can be this point, and this point. So of the calculations, you will realize this is the point where it is the furthest away. So let's do that. So the point P will be the point 6, 2. So 6, 2 will be. Question number 26. The two sequences have 1, 3, 5 as their first 3 terms. In the sequence, each term is 2 more than the term before it. So which means the difference is 2 between each term. Find an expression in terms of n for the nth term. So since the difference is 2, we have 2n. Let's write down 2n. So now, if the term was the first term, let's say if n was 1, but we replace 2, 1, so this will be 2, but the actual value is 1. So by how much we need to change the 2 to get 1? We need to minus 1. So which means the n term will be 2n minus 1. That's the n term of this sequence. So let's test it out. If my second term is 3, so let's replace n by 2. So we have 2 minus 1, so that will give me 4 minus 1, which is 3. Let's test the third term as well. So my third term is 5. So if I do 3 minus 1, which is 6 minus 1, 5. So yep, it is good. So my nth term is 2n minus 1. So now, the kth term, we don't know what term is this, is 841. Find the value of k. So we replace k by n, so k minus 1 equal to 841. Find the value of k, so 2k equal to 842. K equal to 842 divided by 2. That will give me 421. K is 421 term. Okay, now part B. The nth term of the second sequence is this. That is given to us already. Find the fourth term. Fourth term is when n equal to 4. So we replace n in this equation. So we get 2 power 4 minus 1 minus 4 minus 1, 4 minus 4, that will be over 2. So 4 minus 4 is 0. 0 times something is 0. So this whole thing becomes 0. So 2 to the power of 4 minus 1 is 2 to the power of 3. minus 0, so that will be 8. Okay, now part 2, find the fifth term of this sequence. So when n equals to 5. Okay, so let's replace back the values in the function. So we get 2 power n minus 1 minus 5 minus 1, we get 5 minus 4 over 2. Now we have to simplify. So 2 to the power of 5 minus 1 is 2 to the power of 4 minus 5 minus 1 is 4 times 5 minus 4 is 1 over 2. That will be 2, so 2 to the power of 4 is 16 minus 2, that will be 14. So the fifth term is 14. Question number 27. So the diagram shows the speed time graph of a car which slows down from 30 ms to 12 in 20 seconds, then continues at the same speed of 12 meters per second, straight line. So part A, find the retardation when t is equal to 10. So find the retardation when t is equal to 10. So retardation is the gradient. So it will be the distance of this will be 18 divided by the base will be 20. That will be 9 over 10, 0.9. So retardation at time equal to 10 is 0.9 meter per second square. Okay, so now part B, find the distance traveled by the car between time t equal to 0 and t equal to 20. So distance travel is really just distance, so area under the graph. So we can see that this area from t0 to t20 is a trapezium. So we will do, so this length is what? This length is equal to 30 and this length is equal to 12. And the height is 20. So how to find the area of a trapezium? We have to do half times the sum of the sides, which is 30 plus 12. 30 plus 12, multiply the height, which is 20. So now we simplify. We will have 30 plus 12 is 42 times 10, which is 420. So the height of, so the distance traveled is 420. So now we say the distance traveled, part C, by the car between time equal to 20 and time equal to k is 60 meters. Find the value of k. So we are saying that the area under this graph is 60 meters. So this distance is what? It's k minus 20 and this height is 12. So it is area of a rectangle. So we do k minus 20 times 12 equal to 60. So this will be k minus 20 equal to 5, k equal to 25.